We have a next speaker from NTPC, Mr. Sumit Kumar Halder, DGM NTPC. He'll be speaking on role of cutting edge in enabling sustainable automation for energy transition. Please welcome him on the stage.
Honorable dignitaries present in this August hall. Unfortunately, my group head, Shri Praveen Kumar Gupta, he had to be there today. So he is unwell. So I am there to, take up the part and, bring forth the journey of NTPC in interesting times ahead. So our topic is role of cutting edge technologies in sustainable automation for energy transition. Energy transition is the buzzword of our industry, the generating industry. We generate power using fossil fuels, mainly coal in India, and to say so, it's a dirty kind of consideration, right? So the power we generate from, we actually pollute, and that is the thought process. But I would like to put forth, and because we are the end users over here, and all technology leaders are there, so we'd like to put forth our perspective or our outlook as to how technological intervention, various things which have come up these days, or the various developments which are coming up have and are going to impact the generation industry as well. So intent is basically we'll start with the overview of energy transition taking place in NTPC, and then control systems and instrumentation in thermal power plants, cutting edge technologies, which as per our understanding as an end user, which would affect or which would shape the next gen in power generation, and then the underlying threats which come with hyperconnectivity in the modern world, then digitalization, where NTPC has set forth and whatever we could do till date, and whatever we plan to do, and the vision ahead. So, sir, NTPC, if you see at a glance, we are majorly thermal coal generating company. Then we had a presence in gas. Then we manufactured or we developed CCPPs, combined cycle power plants, along with thermal generating units, right from 1975 when our inception was there. And then from there to hydro, we diversified. We got solar into our portfolio, wind, and slowly and steadily, we are turning the face of India into a greener, greener country, with NTPC trying to shift focus to greener generation. Now we have unparalleled presence across the country. So while we generate around 17% of the total power, okay, means in terms of installed capacity. However, we are while our installed capacity is 17% of the total capacity as on date, we generate around 24% of the total power in terms of billion units for the country. So when you had 1317 in 2024 for the rest of India, NTPC generated around 422 billion units. Then we have very strong growth drivers in the power sector, and because India's GDP is growing at a very, very brisk rate, we are the fourth, as we say, will surely become the third largest economy. We intend to go further in that, crossing 5 trillion, and NTPC is one amongst the backbone industries in this country, which will power India's growth, because it is a key infrastructural requirement, power you require for all kinds of other developments to take place. So, what we intend to be in 2032 is a 130 gigawatt plus organization with, with commitment on RE front. We have a commitment of 60 gigawatt. We are leapfrogging in our ESG as well. We have never been traditionally, to be very honest, we have been a laggard in the ESG performance areas, but in the recent years, we are doing quite well, and we intend to do better. For that matter, Adani generation are doing good, but then NTPC is catching up, and we intend to, be the topmost ESG topmost company in the country in power generation with regard to ESG as well, ESG compliances as well. So by 2032, NTPC intends to become an integrated energy company, and that's where sustainable generation and in this era of energy transition, it becomes very, very important. So as of now, we are into, say, coal-based generation, renewables, and coal mining for power generation. So we will become probably by 2032 the biggest RE company. Okay, we will be having portfolios everywhere: carbon capture, utilization, storage, then green mobility, nuclear is a new era wherein NTPC along with NPCIL have gone ahead. So there are interesting times and opportunities for everyone present in this August hall, and as our partners, and for NTPC and for India as such. So this is in general, what we intend to have. We intend to set up a complete, hydrogen-based economy in hydrogen-based generating, as well as developing products related with hydrogen generation in and around Pudimadka. So with this, we are moving a step ahead. We are playing our part in making India net zero by 2070. And then we are repurposing our thermal power generations. See, in coal power plants, what we are doing is 100% torrefied biomass firing. Actions taken as of now is 20% co-firing demonstrated at Anwar. So these, at small scale, we are doing these kind of POCs, proof of concepts, and other projects, and thus trying to see and interface in our existing fleet as well as in our new fleet, which we'll be having, or the newer thermal power generating stations, which NTPC is going to get from through our partners like BHEL and L&T. There we have these kind of interventions or these kind of solutions put in place so that our overall carbon dioxide footprint keeps on coming down. So then in methanol co-firing, ammonia co-firing, this is in case of thermal. Then nuclear SMRs. So this is with regard to NTPC's tie-up with BARC. So we have an understanding with MOU with BARC, and we are trying to develop, co-develop, in fact, SMRs, get into that area, which is really niche. So that is still in the fray. Then grid services. Then on the gas power plant front, methanol co-firing, hydrogen co-firing, ammonia. So this shows the seriousness of NTPC in this area. So NTPC has got, and these are our sustainable initiatives to prove our seriousness, prove our efforts, our sustained efforts towards getting a greener and a brighter future for us and for the country. Our commitments towards net zero, towards emission control, towards biomass co-firing, and then this NTPC Brighter Plan 2032, which says that by 2032 we'll have 60 plus gigawatt of renewable generation from NTPC. That's how there's a shift which is taking place. So the nuclear business, as we say, exploring SMRs with the BRC, and thus see, from traditional thermal generation to setting its foot into every aspect of the energy value chain, NTPC is being supported through by the automation, by control and instrumentation, the department to which I belong. And see, the control and instrumentation industrial automation journey has been really fascinating, right? From 1950s to the present day, from the early automation with relay control systems to this day with Industry 4.0, the gap between IT and OT becoming more, more transparent, or things are merging, and the integrated networks, software systems, and from here now to the age of era, to the era of AI. And I beg your pardon if I fumble a bit. So it's a real fascinating journey which is there, which we all are witnessing. And era of AI, right from machine learning, then slowly into to deep learning, computer vision, then natural language processing, NLP, natural language processing coming to the forefront, excessive research in NLPs, moving towards, towards transformer, VAEs, variational autoencoders, then then transformers, and then to language models, from small language models to large language models to multimodal AI, so on and so forth. And the area is expanding. So all that coming under the gamut of generative AI. And now in today's date or today's era, agentic AI, which is taking the forefront, and almost, definitely the AI leaders like you people, many of you are actually working into it. However, those have not really entered into the automation value chain per se, and we are still majorly following this ISA 95 Purdue model. But then, and this has helped us. So this has sustained. So for so many years, with different kinds of systems and systems at various levels and connectivity between them. In fact, in terms of cybersecurity, they say this is really robust. But then, with the coming age, this also intends, this also will have some transformation to see. So this thermal power generating the generating company, the major control system is a distributed control system, safety, precise regulation, tighter integration, so on. And these are the very critical aspects based on which our DCS controls are designed. BHEL has been doing it for NTPC for years together, L&T, then so many, Yokogawa for that matter, Emerson, Honeywell. And our journey of control systems is right from 1977-78, from relay-based systems at Singrauli 1. These are our legacy power plants which are still running thanks to the efforts of our partners and NTPC. The way we have run the power plants, we are able to generate and sustain our business with these in these companies as well. So relay-based power plants to microprocessor-based FSSS in Farakka, then in Vindhyachal, the first DDCMS, or this is the term which, as an end user, we have given to the today's world, DCS, distributed control system. We call it distributed digital control monitoring and information system, right? And then to Talche, to Ramagundam, Rihand, we had PLC-based controls for all our offsites. And then what we did is we started conceptualizing, even DCS for offsite. So this is a general development of NTPC. I thought I would touch base upon it so as to show our commitment towards automation and inception, or accepting, automation development, with time. So right from this kind of transition, from the earlier stations to we have come to LVS-based operation, right from our Talcher, and this is what is continuing even till date. And we have changed in LVS technology as well. We have gone for DLP and even 4K as well. 4K fine pitch LEDs have now come as a part of our HMI front end. Sensors. So there has been a development, a rapid development in sensor technologies, and we have adopted, or we have kept up with the change in development of sensor technology also. We have had our own issues or troubles with instrumentation, especially with SEMS, continuous emission monitoring systems, and we are still developing the systems. And we have also incorporated field bus-based systems, though, to be very honest, this started in oil and gas quite some, in the late 90s, right? We have been a slow adopter of, we have adopted it, say, over 15 years hence. But then after that, because of NTPC adoption and because we provide consultancy for thermal power generating companies all across India, now field bus is a very regular feature in generating stations. This is typically which I would like to emphasize. Now we are also moving ahead, looking at the new developments in the field bus technology, and we'll put forth that in our technical specs as well. The environmental problems, as I said, the development in that has always also taken up. Now, with all these, and as a basic of thermal power plant instrumentation, what we find is that in today's world, AI, ML integration, edge computing, and 5G connectivity, these three, if we can identify some of the technologies which have actually affected, or which we are considered are actually going to affect generating stations, are these three key technologies. So, AI ML integration in life cycles. So for example, we know how machine learning works. You have got a lot of data storage, then there is data cleaning, ETL you do, then you train models, etc. But then online learning, continuous learning, and continuous updation of models, and observability of the models developed. These are very, very key factors. And they are going to affect, as we say, they are affecting, they are going to affect. So edge computing development in in the field of semiconductors, in the field of microprocessors, ICs, and and shifting of the majority of computation on the edge has helped us in prolific IoT integration and development with IoTs. So this is what we had thought for our asset management, how NTPC can go ahead with asset management with incorporation of IoT for asset monitoring, then mobility application, real-time location systems, asset information management for taking this data over a wireless infrastructure, then performing RCM. Though RCM we could not incorporate as of now, but yes, we are looking forward towards integrating in our asset management solution, analytics and dashboard platform as well. Now, WANs beyond wires for digital transformation, where 5G is something which I was talking about. CNPN concept is gaining traction these days, and in thermal generating units, we are just thinking of setting up that is captive non-public networks using 5G, so as to incorporate, or so as to assimilate the exceptional or the huge amount of data which can be obtained through IoT devices over over wireless. And ingestion is definitely an issue, because then the infrastructure, if you consider just the common wireless protocols, that is ISA 100 and 62591, our understanding is that requires a huge infrastructure setup. However, with 5G and upcoming 6G, it is quite possible to get that, and that too in a secure fashion. So we request the industry to look towards it, because our understanding is that there is a huge potential in this. And then wireless, then with 5G, because the latency gets reduced drastically, and it can become a primary network for communication, as well as can be introduced into controls. But that is something for the OEMs or the real technology developers to look into. But this is our thought process. Now all this into the DCS structure, the control system layer, which NTPC thrives upon, we find that this kind of a connectivity might exist, or say and when I say next generation, is that in the newer generations we might accept more of IT/OT connectivity, and this and more of wireless connectivity in the generation. Further, then this open architectures are also something which we are seeing here. OPC UA becoming the backbone over which industrial Ethernet, and Ethernet at various levels, right from the field to the control level till the corporate is getting developed, and everything is getting connected over OPC UA. So this also we feel is going to play a part, and it will be incorporated in the DCS architectures sooner or later. So, so this is the development, right, from point to point to IC 61152 58-2 based field devices, which till which we are there, we are we are having this in NTPC and the other projects where we are consulting. And then shifting over to Ethernet field devices, then APL field devices, I believe it is still development taking place. And others, you are there to provide more knowledge further, but till now our understanding is that still we have to catch up in this area. This is where we think the modern control system architecture would be over the OPC UA backbone and Ethernet APL at the field, industrial Ethernet and the corporate Ethernet, and every kind of devices, different protocols connected together. And then, this sensor technology development, and this taken from, Yokogawa. So fiber optics are playing a critical role. Fiber optics sensors like DSTX for temperature measurement, and similarly for acoustics, for strain measurement, they will play a critical role in the new architecture of control systems which we have for sustainable development. And then these are the threats which are there. So you see, OT is the superset of everything, right? And so many other things are coming into OT as well. Confidentiality, integrity, and availability. Just a minute. In our area, we are very, very particular about following 62443. For that matter, we specify 62443-4-2, 3-3, and 2-4 in our technical specifications for all new DCS suppliers to follow. Then very quickly going through the digitalization. So these are the new technological areas where we intend to focus as engineering, as a think tank from NTPC perspective, and we are open to discuss with everybody and see and find out where people can support and what all you can bring it to the table. Digital twin, in case of digitalization, is the single most significant initiative within NTPC, and it is at the base of everything in NTPC. In thermal generation, we focus on 3 digital twins: the thermal digital twin asset and the process digital twin. Thermal digital twin is helping in our advanced process controls, the asset digital twin for identification of all assets, and the process digital twin as to visualization of the various systems and processes in our thermal generating units. And this is where we are considered. So this advanced process control based on, because of flexibilization, see, nuclear generation, you do not flex the units, but in thermal generation, you are required to flex, you are required to bring down the load with a lot of RE integration, renewable integration per se. So we need advanced process control, and that NTPC has adopted successfully. This is one solution which we have developed in-house, and we had got the patent for this as well. This is also a work in progress as to boiler and turbine health monitoring. As you know, that we have a lot of legacy systems where the thick-walled equipments were not really meant for variable load operations. So we need to monitor the health of these equipments greatly, and we take help and support from others as well. So in these are the requirement of grid, and we have successfully integrated through in-house technology as well as support from the others. And then predictive machinery management and condition monitoring is something where we intend to put in our specifications, and we seek active support from solution providers like Yokogawa, ABB, and others, even for Marshall and others. Integrated coal transport management system was one initiative we have successfully implemented in one now plant in North Karanpura, where the complete coal is getting transferred through trucks. And this is a beautiful system making use of IT, modern IT technologies. This was a system for early warning of hydropower projects which NTPC developed in the wake of the big disaster which took place at our hydropower plant at Tapovan Vishnugar at Chamoli on 7th February 2021. So we have we set up a beautiful system for monitoring the 2 different rivers, then the flood over there, and monitoring the and in the comprehensive. In the next stage, will be monitoring the peaks as well, the Himalayan peaks as well, through advanced sensors like radar, etc. That is there in the fray, that is in thought process. We have adopted this, which is there in the which is very much prevalent in Europe and Australia. This is advanced monitoring of stockyard for NTPC. And these are this is very small, outlook of what C&R department, control and instrumentation, has done for digitalization in NTPC. Now, this is a very interesting concept. See, this was published in the Energy Transition Policy Research Group, and this is something which my director of projects professed upon very, very strongly. So we are a dirty generating company as per se, right? There's a CO2, generation, CO2 per kilowatt hour is 938 grams. So if we move towards ultra supercritical technology, which we have won in our new power plants, so we can reduce it to 800 grams. Then with 20% biomass co-firing, which we had shown earlier, we can bring it down to 640 grams, 20% carbon capture, then we come down to 490 grams. And then this USC 20% and 20% this carbon capture and 20% biomass. So 490 grams is something which even the CCPPs worldwide are also emitting. So they call it blue thermal generation. So we can be there. And with SMR integration in thermal generating units means with smart modular reactors also there in place, it can come down to 330 grams. This is a concept which NTPC is professing, and all that for sustainability, for greener generation is possible only through digital transformation. And then proper simulation. Agentic AI is one thing which we would like to focus upon, or just bring your attention to that. This is what is coming up. And from agentic AI end, then we might move slowly from the phase of artificial narrow intelligence to artificial general intelligence in times to come. But then we require the industry to provide solutions for the generating sector as well in these areas. So we had Yokogawa sometimes back who had come with their FKDPP algorithm, which they have implemented in the refineries. We seek their guidance and support for similar kind of implementation in generating systems as well. Agentic AI workflow for autonomous systems. Here you see LAMs, large action models. This might be a new term, but large action models are getting integrated with the whole agentic process to, to automate the decisions which come through machines without human intervention. And then human-machine collaboration in Industry 5.0 and X. So this is where we understand that with agentic AI systems in place, and with the existing technology, and with humans to support, or with human feedback in the loop, or with the human in the loop, there will be a more collaboration. There will be lesser losses. There will be we will aid towards a circular economy and exceptional growth. So I think I have taken a lot of time of yours, but probably as an end user, this perspective was important to be brought in front of the industry leaders. Thank you very much, sir. Thanks for the opportunity given.
Thanks, Mr.